What's up, everyone? Welcome back to another video. So in this video, we're going to understand why we need to use mutexes, what race conditions are in Golang, what Go routines are. We're also going to solve a bug which is present in our code at the moment, and we will start implementing the client side in TypeScript React.js. So let's get started. So in this video, we're going to start by improving the logic that we have in our Go server a little bit. As you can see, we are keeping track of all of our users using just a slice, which is shared among all of our connections. So if you don't know how WebSocket connections work in Golang, whenever a new connection comes in, whenever a new client tries to connect to our web server, we create a new Go routine for that user, which is just like a thread, which will act as the connection, the WebSocket connection to our chat server. And we have one single global user slice. All of the Go routines are sharing this singular slice of users. And this is a problem because it can lead to a bunch of memory issues. And we don't want this in a production environment. This can lead to race conditions really easily. Let's say that if a bunch of different Go routines are trying to update global users at the same time, then we cannot guarantee that it would still have a consistent state once the update operation has finished happening. So in order to keep our access consistent to the shared global users, we'll need to come up with a solution. And the easiest way to solve this is to use mutexes. So we'll import sync. This will have the mutex that we need. So after importing sync, we can add the mutex to our user struct. This will be the thing that will allow us to implement the locking feature that we're trying to use for having access to the user's connections. So now we'll need to look for the critical sections that are present in our code. A critical section is the part of the code which tries to access a shared memory resource where race conditions can easily occur, which is global users in our case. This is the first part where we try to append a new user to our global users. So here we'll first access a lock to the user struct. And once we are done with the operation, we just unlock that part of memory. Anytime a new Go routine enters, anytime a new WebSocket connection tries to enter, and we try to append that user to the global users, we'll first need to access an exclusive lock to the mutex. And once we're done with the operation, we unlock so that other Go routines can now access the lock. A better way of implementing the unlock is to use the defer keyword provided by Golang. And the advantage of using the defer keyword is that let's say that if our critical section was longer than this and it was prone to errors, then using the defer operation would ensure that doesn't matter if the function returns successfully or by an exception, we still perform whatever was given to the defer operation. So we'll do something like this. All it cares about is performing the operation which is provided after the defer keyword, and this will be performed no matter what happens. This is another part of the code which is a critical section. We are gaining access to the user connections. We're looping through all of them and broadcasting the message that we receive. So we perform a lock operation here as well. So I've added the lock and the defer unlock. Anytime we want to broadcast, we first gain access to the mutex lock, and only then we can perform the operation provided here. And once we leave the function, we will perform the unlock operation. Also, those were the two places where we are gaining access to this shared slice of users. And now we've implemented a way to lock and unlock such that we can make sure that this vulnerable piece of memory is only accessed by one Go routine at a time. We don't perform concurrent updates or read operations to this connections slice, and this will make sure that we don't have any race conditions in our application. Now let's try to run our server and test this thing out. I've made two tabs here. Let's create our socket and let's send a message. You see that the message is received on the other user. All right, so our locking system is working. Our mutex is working correctly. And just to reiterate, this now prevents any race conditions that might occur while updating the users. So I've noticed another problem that we have with the way we are broadcasting and handling our users. So if you notice, when we have an issue with the WebSocket connection, then we're just printing out the message and returning out of the function, which means that the WebSocket connection is disconnected, but the user is still kept track of in our global users. We are not removing that user from the slice that we're keeping track of. So we'll need to implement a remove user function similar to our add user function. So this is what the remove user would look like. It's going to take the WebSocket connection that we are trying to get rid of. First, we handle the mutex, the lock, and then we loop through all of the users that we have connected. If any user matches the WebSocket connection that we're trying to remove, we just get rid of that user from our user.connections. And if you don't understand this syntax, what we're doing here is, since the user we are getting rid of is the ith user, then we're just setting the connections to everything leading up to I and everything after I. So this would get rid of the ith element from the slice. We call the remove user function from wherever an error might occur while receiving or sending messages. So this we've added while an error occurs during the broadcast, and we also remove user while receiving the message if an error occurs. And we see that after we closed the connection from one of the users, we only have one user in our global users. We can now move on to creating a client for our chat application. So we'll just get out of this directory, and we'll create a new client directory, let's cd into it, and we'll create an empty React app which will use the TypeScript template. All right, so now that we have that set up, we can look into our client folder and we have our React app set up. If we run npm start here, we see our basic React app running here. Now we'll delete some of the things that we don't need for our application, more stuff we don't need, deleting references to all of the things that we just deleted. I'm going to start by adding the CDN for Tailwind CSS in our index.html. This is the fastest way of using Tailwind in the React app. We'll need something like a chat window and a chat input. The input will be something with just one input field and a submit button, and the window will show the history of the chat that we've had. So we'll need a use state with the messages, and we can pass those messages to the chat window. We'll also have an error in case if the chat server crashes or we stop the server or some sort of an error occurs, we need to handle those errors here, and we can use a separate component for rendering the error. Now let's create all of these components that we need. So I've created a really basic error component which just has a message that is passed as the error message, and we'll have a button which will just reload our page in case of the error. I've also created a simple chat window component. It'll just take the messages that are coming in and it will map through all of the messages, and each message is rendered as a list item. We'll also import that into our app. Now I'm going to create a handle send message. This will be the event handler for our chat input. And I'm going to pass the handle send message to the chat input as a prop. Now the way that I've implemented the chat input is we're having another use state here, which will just uh, be the input that the user enters for the message, and we'll have a form which will have an on submit. And I've written a separate handle send message within this, which will just firstly prevent the default action. So the default would just reload the page. We don't want that. So we add that. We call our on send message, which was passed as a prop, and we set the message to again an empty string. And then we'll have an input and a button which will be a submit type, and we import that as well into our app. So now that we have all of this, this is what our React app looks like. I'm going to add a bunch of Tailwind styles to our whole application. So there we set a bunch of styles. We set some styles for the input form and the button, and some styles for the chat window. Also, almost forgot about the error. So we add a bunch of styles there. This is what our app looks like now. Let's just set a minimum height for our window. All right. So now that we have set a height for everything, let's try to send a message, and we see the messages showing up. So the next step would be to create a use effect for our entire application. So on the first load, we want to establish a connection with the WebSocket server that we've set up. We import use effect. Now here we can write all of our logic for setting up the connection. We'll also need a use state for the socket itself, just to check if we have an available socket connection, and we set up our WebSocket connection on load. I've provided the localhost 3001 port as our socket address, and a cleanup function which will just close the WebSocket connection whenever we detach our component from the DOM. I've added another use effect here, and this will be specific to the socket that we have. The other use effect we had was for just the first time that we load our application. This is whenever something happens with the socket, if some kind of an event occurs with it, we're setting up a bunch of event listeners to our socket. So on close, we'll have an event listener which would just set the error to connection lost with the server. If let's say the connection is closed from the server end, then we set the error to that message. and the error will be shown to the user. And similarly, whenever a message is received from the server, we'll need to check what kind of a message it is and handle it accordingly. So we see that now if we reload our page, we see the connection is lost with the server because I'm not running the server right now. So I've just started our Go server. Now, if I reload the page, we don't see that error anymore because we now have a working connection, a working WebSocket connection to our chat server. Okay, cool. So this was our video. So in the next video, we will be adding a bit more functionality to our client and figuring out how we can send JSON data from the front end and parse it in the chat server. And we can look into how we can send different kinds of messages to the server. So stay tuned for that video. Until next time, thanks for watching.